Hey everyone, welcome back to the channel. Today we're diving into one of the most crucial aspects of natural language processing, evaluating NLP models. You've built an amazing language model, but how do you know if it's actually good? How do you compare it with other models? That's exactly what we'll cover today. We'll explore key evaluation metrics like BLEU, ROUGE, F1 score, and Perplexity. Plus, we'll look at benchmark datasets that researchers use worldwide to compare their models. By the end of this video, you'll understand exactly how to measure your NLP model's performance. So let's get started. Before we jump into metrics, let's understand why evaluation is so important. Imagine you've trained 3 different machine translation models. Model A seems fast, Model B produces fluent text, and Model C is somewhere in between. Without proper metrics, you're just guessing which one is better. Evaluation metrics give us objective, quantitative ways to measure performance. They help us answer questions like, is my model improving with more training? How does it compare to state-of-the-art models? And is it ready for production? In industry, this matters even more. A 2% improvement in translation quality could mean millions of users have a better experience. But you need metrics to measure that 2%. Let's start with one of the most famous metrics in NLP, the BLEU score, which stands for Bilingual Evaluation Understudy. BLEU was originally designed for machine translation, but it's also used for text summarization and image captioning. The core idea is simple. Compare the machine-generated text with one or more human reference translations. BLEU measures how many n-grams, that's sequences of words, in the machine translation appear in the reference translations. It checks unigrams, bigrams, trigrams, and 4-grams. Let me show you an example. Suppose we're translating from French to English. Reference, the cat is on the mat. Candidate is the cat is sitting on the mat. BLEU will count matching unigrams, the cat is on the mat, that's 6 matches. Then matching bigrams, the cat is, on the mat, that's 4 matches, and so on for higher n-grams. Let's look at how to calculate this in Python using the NLTK library. We import the sentence BLEU function, define our reference and candidate sentences as lists of words, and calculate the BLEU score. A score of 1.0 means perfect match, while 0.0 means no overlap. Here's something crucial. BLEU has limitations. It doesn't understand meaning. It just matches words. So the cat sat on the mat and the feline rested on the rug would score poorly even though they mean the same thing. Next up, we have ROUGE, which stands for Recall-Oriented Understudy for Gisting Evaluation. While BLEU focuses on precision, how much of what the model generated is correct, ROUGE focuses on recall. How much of the reference text did the model capture? ROUGE is particularly popular for evaluating text summarization. Think about it. In summarization, you want to make sure the summary captures all the important information from the original text. There are several ROUGE variants. ROUGE N measures n-gram overlap, similar to BLEU. ROUGE L looks at the longest common subsequence, and ROUGE S considers skip bigrams, allowing for gaps in matching words. Let's see an example for summarization. Original text, the company reported strong earnings growth in Q3, driven by increased sales in Asia and Europe. Reference summary, strong Q3 earnings from Asian and European sales. Generated summary, the company had strong earnings in Q3. ROUGE 1 would measure unigram overlap between reference and generated summaries. Here's how to calculate ROUGE in Python using the ROUGE score library. Notice we get precision, recall, and F1 for ROUGE 1, ROUGE 2, and ROUGE L. The beauty of ROUGE is that it tells you if your summary is missing important information from the reference text. High recall means comprehensive coverage. Now let's talk about the F1 score, a metric you've probably heard of in machine learning, but it's super useful in NLP too. F1 score is the harmonic mean of precision and recall. It's widely used for classification tasks like sentiment analysis, named entity recognition, and question answering. The formula balances precision and recall. F1 equals 2 times precision times recall divided by precision plus recall. This means a model needs both high precision and high recall to get a good F1 score. Let's say we're building a named entity recognition system to identify person names in text. Text: Barack Obama visited Paris with Michelle Obama. True entities: Barack Obama, Michelle Obama. Predicted: Barack Obama, Michelle Obama, Paris. We correctly identified two entities, but also predicted Paris as a person. So we have precision equals 2/3 equals 0.67, 2 correct out of 3 predictions. Recall equals 2/2 equals 1.0. We found all actual entities. And F1 equals 2 times 0.67 times 1.0 divided by 0.67 plus 1.0 equals 0.80. Here's how you'd calculate F1 for a classification task using scikit-learn. We can calculate it per class or get a macro or micro average across all classes. F1 is perfect when you need a single metric that balances both false positives and false negatives. It's especially useful when your classes are imbalanced. Now for something a bit different: perplexity. This metric has a fancy name, but the concept is actually intuitive. Perplexity measures how well a language model predicts a sample of text. Lower perplexity means the model is less confused or perplexed by the text. Think of it this way. If a language model sees the sentence, "The cat sat on the," and has to predict the next word, a good model would give high probability to mat, floor, or chair. A confused model might give equal probability to every word in the vocabulary. Mathematically, perplexity is 2 to the power of the cross-entropy loss, or you can think of it as the exponential of the average negative log likelihood. Let's say we have 2 language models. Model A has perplexity of 50. Model B has perplexity of 150. Model A is better. It means, on average, Model A is choosing between 50 likely words, while Model B is confused between 150 words. Here is a simple implementation. We calculate the cross-entropy between the model's predictions and the actual next words, then take the exponential. Perplexity is the go-to metric for evaluating language models, especially GPT-style models. It's used in training to track improvement and in research papers to compare models. But remember, lower perplexity doesn't always mean better text generation. A model could memorize the training data and get low perplexity but fail on new inputs. All right, we've covered the metrics, but metrics are meaningless without good test data. That's where benchmark datasets come in. Benchmark datasets are standardized test sets that the entire research community uses. This allows fair comparison between different models and approaches. Let me walk you through the most important benchmarks in NLP. First, we have GLEU and SuperGLEU, the General Language Understanding Evaluation. These are collections of diverse tasks like sentiment analysis, textual entailment, and question answering. If you want to test general language understanding, GLEU is the way to go. Next, SQUAD, the Stanford Question Answering Dataset. This contains reading comprehension questions where the model must find answers within a given passage. SQUAD 2.0 even includes unanswerable questions to really test the models. For machine translation, we have WMT datasets. The Workshop on Machine Translation releases new datasets every year with multiple language pairs. And for summarization, there's CNN, Daily Mail, and XSum datasets containing news articles and their summaries. Most of these benchmarks have public leaderboards where researchers submit their results. You can see exactly how your model stacks up against GPT-4, BERT, or the latest research models. Here's a pro tip. Always evaluate on multiple benchmarks. A model that excels on one benchmark might fail on another. You want robust, generalizable performance. And be careful about data contamination. Make sure your training data doesn't overlap with test sets, or your metrics will be artificially inflated. Now let's put it all together and talk about how to actually compare models in practice.
When comparing models, you typically create a table like this, showing multiple metrics across different benchmarks. This gives you a comprehensive view of performance. Here's what's interesting. Different models have different strengths. Model A might have the best BLEU score, but highest perplexity. Model B might be slower, but more accurate. Model C might be the best all-arounder. Let's look at a real comparison scenario. Suppose you're choosing a translation model for production. Transformer base, BLEU 28.4. Speed 100 cents per second, model size 65 params. Transformer big, BLEU 31.5, speed 40 cents per second, model size 213 params. Custom model, BLEU 30.1, speed 80 cents per second, model size 95 params. Which is best? It depends on your constraints. If speed matters most, base wins. If quality is paramount, go with big. If you need a balance, custom is your choice. Here's a simple Python function to compare multiple models across metrics. You can use this to generate comparison tables and even visualize the results. One more crucial point. Always check statistical significance. A difference of 0.1 BLEU points might just be random noise. Run multiple evaluations or use statistical tests to verify improvements are real. Before we wrap up, let's talk about the elephant in the room. These metrics aren't perfect. BLEU and ROUGE can't capture semantic similarity. F1 doesn't tell you about the quality of predictions. Perplexity doesn't correlate perfectly with human judgment of text quality. For instance, these two translations might have very different BLEU scores, but the same meaning. The student reads books versus the pupil peruses literature. Traditional metrics would penalize the second one heavily. That's why researchers are developing learned metrics, like BERT score, which uses contextual embeddings to measure semantic similarity, or BLEUert, which is trained on human ratings. But here's the truth. Human evaluation is still the gold standard. Metrics are approximations. For critical applications, you should always include human judges to assess quality, fluency, and faithfulness. The future of NLP evaluation is moving to more semantic, context-aware metrics that better align with human judgment. It's an exciting area of research. All right, let's recap what we've learned today. We covered 4 essential metrics: BLEU for translation quality, ROUGE for summarization recall, F1 for classification tasks, and Perplexity for language model confidence. We explored major benchmark datasets like BLEU, SQUAD, and WMT that researchers use to compare models fairly. And we discussed how to compare models in practice, considering multiple metrics and trade-offs. My advice when evaluating your NLP models, never rely on just one metric. Use multiple metrics, multiple benchmarks, and when possible, get human feedback. If you found this helpful, smash that like button and subscribe for more NLP content. Drop a comment below telling me what NLP topic you want me to cover next.